Running databases on Kubernetes is scary. Everything is supposed to be stateless, right? All wrong. I've been running databases on Kubernetes for several years, both at home and in production at work. And in this video, I'm going to teach you everything you need to know to start running databases on Kubernetes. So let's jump in. We are going to be using the CloudNativePG operator. And an operator is something that enables custom resources to be deployed on your Kubernetes cluster. And that's something that I'm going to show you right after this. But this is an open source community-driven operator that you can install for free. And actually on my home lab, I'm using the EDB operator, but now they have moved to a subscription model, so it's not free to run anymore. So in this tutorial, we are going to be using the 100% open source CloudNativePG operator. So I've prepared a few notes here, and the cluster that we're going to be using is an AKS cluster that I have just deployed in my Azure resource group here. So let's jump in. First of all, we need to install the CloudNativePG operator. And this is really easy to do. We just go to the CloudNativePG documentation, and then we are going to go to the quick start. And here we have a link to installing CloudNativePG. So you can either just apply the manifests, or we can use the CNPG plugin to install it, or you can use Helm, but I'm just going to use the this little manifest over here. Copy that. And I'm now here connected to my fresh AKS cluster, kget nodes. Here we see I have 2 nodes with an age of 7 minutes. And if I now apply this manifest, we are going to be installing the CNPG operator. So if I do kget-ns, then we see we have a new namespace here called CNPG system. So now that we've installed the operator, let me just explain a little bit why you should be running databases on Kubernetes and why it's not scary. Because indeed there is this idea that all Kubernetes clusters need to be stateless, and you should never run any state in your Kubernetes cluster. And to some extent that's true, but when you're running databases, you have methods of replicating those databases to object storage. So the actual state doesn't necessarily exist in your Kubernetes cluster. So I'm going to be showing you what I mean by that as soon as we create a cluster here. And in order to create a cluster, we just take this bit of YAML here, and I'm just going to copy that, and I'm going to open a new file and paste that in. So what we see here is I'm going to be creating a namespace, and I'm going to create a cluster resource. So this resource is a custom resource that has been enabled by installing the operator. So if I do kget-crd, then you see here, these are all the custom resources that live on my cluster. And here, for example, we see that we have a backups custom resource, but also a clusters custom resource. And that's being installed by the PostgreSQL CNPG IO API. So opening that again, we are deploying a cluster with the name demo cluster in the namespace database. Good, I caught that there. And the instances, the amount of instances we're deploying is 3. And each of them has 1 GB of storage. So then I just apply that database.yaml file. And now we see that we have created a cluster. So if I now change my namespace to database and get my pods there, here we see that now an initdb pod is running. So what this does, it is preparing the database to be deployed. It's provisioning some storage for it, and it's bootstrapping the database itself. This takes a few moments, but as soon as this initdb process has finished, then we'll see that it's now initializing the first instance of the actual cluster. So a new pod is being created now. And that takes a while because it needs to pull the image, of course. But now we see that it is making progress, it's running, And now it's just waiting for the readiness probes to become ready. And now the first instance of my cluster is actually running. And now it's going to create a second instance in a second pod, which is then being joined to the Postgres cluster. So what I can do now, I can go get pods. Here I see my pods being created. But now that we have the operator installed, we can use the CNPG kubectl plugin in order to interact with our clusters. So first of all, I can do get clusters. Here I see if I get cluster, then I see that I have my demo cluster over here, waiting for the instances to become active. But if I then do CNPG status and then select this cluster, then we see that we have this CNPG plugin is able to give us the status of the cluster itself. Now we're seeing that it's waiting for the instances to become active. We have an overview of our instances. So we see that we have a primary, which is now in an OK status. This one is still being worked on. So if I rerun the status command now we see that we have 2 instances. And it's now probably busy creating the third one. Yes, we see here that the third one is now in an init state. So the cluster is now being provisioned all automatically just by applying this little YAML object. That's how easy it is to provision a cluster. Now, of course, this is a very basic YAML object. But if I go to for example, my home lab repo, and open up my LinkedIn database for production, then we see here that I have a few more things that I configure. So I can configure that it needs to bootstrap from a backup that I've created earlier and where that backup is located, etc. And you can also, for example, configure the resources that it needs to run, that you're requesting. So there's a ton that you can configure with this, but we are just doing a very simple deployment for now. So checking our status is now in a healthy state, as you can see here. But we can also do a verbose status. And now we see that we have get some more information. So we have some information about the pod disruption budgets. So that it does that automatically as well. So if I do get PDB, then we see here that we have a cluster with a pod disruption budget here as well. And this is going to be useful in the next section. So if you are interested in learning Kubernetes, if all of this is magic for you still, then I highly recommend you join my DevOps community. In here, I have courses on the Kubernetes fundamentals, a full Kubernetes roadmap, and I have the only Kubernetes home lab course in the world on the internet available for you. It's an 8-hour course, including the fundamentals course, which is also 8 hours. This will teach you Kubernetes on a level that is unprecedented. It's all practical and it's theory-based, but I bring everything into practice as we learn it. So it's a hands-on way of learning. Secondly, you can network with over 400 engineers here. You can ask questions. And I host several group coaching calls every week where you can ask me questions directly, or you can ask questions in the community when you get stuck. Check it out. I think you might like it. So now that we have our cluster running, our database cluster that is, now let's check out what we can do with it. So if I open up K9s again, and if I then attach to one of these instances, and if I then run PSQL, now I have an interface to my database. I can do L, and I see that it has created an app database automatically. The standard name for these databases that it uses is app. So if I connect to the app database, then I can list the tables. Well, there isn't anything in there yet, so let's create something. So here I have a very simple SQL script, and this is going to create a users table, and it's going to insert Alice and Bob into that table just for demonstration purposes. So if I now, this is now created, and if I now do select star from users, then we see that we have Alice and Bob in our database. So now that we know how to interact with the cluster, let's do something else. Let's say we have created our cluster, but then we want to apply some changes to it. Well, we can just open our database.yaml, and let's say I want to increase my instances to 15. I have a very important cluster, and I want to have 15 instances of my database here. So if I apply that now, then it's going to apply this. So if I do kget pods now we see it's going to, one by one, it's going to increase the replicas. And this is going to take a while because it needs to join and then replicate the database to it. But eventually we're going to have 15 replicas of our cluster ready here. So while that is running in the background, this is going to take a while. Let's check out how we can connect to this database and what that does in the background. So when I created the database, then the operator then created some secrets for us. So if I do kget secrets in my namespace here we see that we have a demo cluster app, which is a basic auth secret. So if I open that in K9s, then it's easier to decode. Secret and demo cluster app. Then here we see that it has created a secret with a DB name, with a host, and a password. So here we have all of the connection information available to us in this secret that is automatically created for us. And this, it even provides us with the GDBC connection string. And we can use this or this PostgreSQL URI. And this is the way we can use that in our applications. So if I, for example, grab that LinkedIn application that I just showed you, then this LinkedIn application is configured through config maps. And in my config map, I then can configure the host, the database host that I wanted to connect to. And in this case, it's LinkedIn DB production v6. So in my cluster, if I do kget svc, we see here that the demo cluster, the operator has created a service for this. So you have your read service, your read only, and your read write service, for example. So when connecting to this service, that means that I can actually write to the database. And this is the way that you can formulate connection strings inside of your Kubernetes cluster, because I'm just connecting to this service directly. Then I give it the port and then the database name. And in terms of secrets, then all I need to do is I also, in this case, I'm using the Azure Key Vault operator. But basically what I'm doing is I'm just creating a secret object based from values in my Key Vault. And then I set the environment variable LDDB_user and LDDB_password to the values that were generated by the EDB operator. So this is how you can then connect your applications to it. And another example of this is if I go to my Grafana over here, then I can use these databases as data sources directly. So if I go to my data sources, then here I have my Zettelkasten and Tracker database, for example. And then the way I connect to this is by defining the host URL in the Kubernetes native DNS format. So if I copy this, and maybe it's a bit easier to read that way. So here we see, this is just the standard Kubernetes DNS. So it's the name of the service, and then you're specifying it is then you're specifying the namespace, that it is a service in cluster.local. And this way, I can connect to this service from a different namespace. And because I've done that, I now have my Zettelkasten tracker as a data source here in Grafana. And that means that I can create dashboards out of my data in my Kubernetes database. So the way that works is that I can use Postgres queries like this, select count timestamp as time from markdown counts. And then it's going to render this as a time series because I have a timestamp. And the result is the amount of nodes that are in my Zettelkasten, which I push to an API through a cron job or a systemd timer technically. And every hour that amount of nodes is being pushed. And this way I can keep track of my nodes, for example. Another one that I do is I track my health metrics, so like my body weight and my calories, my body fat percentage, all of that. I'm currently bulking. You can see it's all going up. So I do all of this by pushing that to an API that I wrote myself that inserts all of this into Postgres databases, and then I can query that in Grafana. So you can connect to these databases just by using the local Kubernetes DNS, and it works really well. If there's any application that uses a Postgres database as a backend, in my case, I have my, if I go to my home here, I have my comma feed instance, my RSS reader, my Wallabag, my bookmark manager, and even my N8N. All of that is connecting to their own databases. And this is also how I select self-hosted apps that I want to run in my home lab. I always see if they are using a Postgres backend. That's basically my selection criteria because I really like databases. I like running them. I like optimizing them, and I just like the way the Kubernetes operators, the CloudNativePG operator facilitates running databases on Kubernetes. It's super easy. Okay, I was a little bit overambitious. 15 instances was taking a bit too long time, so I scaled it down to 6. But it serves the purpose. Now I have 6 instances. But now what happens when I, for example, upgrade my Kubernetes cluster, right? All of these are running on different nodes, as you can see here. This one is running on 1, 0, 1, 0, 1, 0. So it's evenly distributed. So that's nice. But what if I am now going to upgrade my cluster? Well, I can go to my AKS cluster here. And for demo purposes, I'm just going to do this from the portal. Usually you would do this when you're, for example, using Bicep. But here I'm going to initiate a Kubernetes upgrade. So I'm going to upgrade to the latest version like that. I'm going to select upgrade control plane and all the node pools. But before I do that, what I need to do is I need to set my cluster into maintenance mode. So what I do is CNPG maintenance set, and then all namespaces. And then now it has been set that the database is now in maintenance mode, which allows it to be rescheduled. So here we see that our maintenance is set to true and reuse PVC is set to false. And this is critical because when you set reuse PVC, then if that's true, then it's going to be reusing the persistent volume claims, and we don't want that. So I'm just going to initiate the upgrade here. So it's now going to start to upgrade. And very soon we should see our nodes starting to be rescheduled. But again, so it's reuse PVC is set to false. So it's not using the same persistent volume claims. Rather, it's just going to spin up new ones and using the Postgres native syncing capabilities to just sync the data to this new persistent volume claim. Because if we do kget PVC, here we see that all of our data is actually stored on persistent volume claims. Each pod gets its own persistent volume claim that contains all of the PG data. And this is also the reason why we can back this up to a different, to object storage, for example. We could actually take snapshots of the persistent volume claims themselves. Or what we can do is we can use the Barman object store, which then points your write ahead log to a object store. So like Amazon S3 buckets or Azure Blob Storage. And then periodically, let's say once an hour, it's going to take a PG dump and back up your wall to the object store. And that means that you always have a snapshot available to you. Let's just see well, it's not starting yet. So what I can just show you is I have my EDB Postgres for Kubernetes dashboard here in my Grafana. This is running in my home lab. And this dashboard gives me a full overview of everything that I need to know of my databases. And here we see that there is also a pane here saying last base backup. So 6 hours ago, my backup, my database has been backed up to the cloud, which I can then use to restore at any point if I want to. When you check out my database.yaml here in LinkedIn, here this is what I meant where I said the bootstrap to recovery, and then it is set to a database called LinkedIn cluster backup, which is then stored in my storage account in Azure Blob Storage. And then it uses just that data over there to replay the wall and to restore the cluster from that backup. It works really well. I've done it several times that I had a power cut and my data got corrupted. You just point it to the object store, it replays it, and it works super smooth. Okay, here we go. Now we see that our new node is being created here with the new Kubernetes version. And now if I open up K9S here, we should see that our pods are now being rescheduled. And we see indeed that it's just taking one by one. It's taking the pod and then it's scheduling it to the new node. And then when that PVC has then been replicated, so when the data has been replicated properly, then it's going to do the next one, as you see here, number 6. And as you see, according to the pod disruption budget, it's just taking its time one by one, rescheduling the pods to the new node. And I don't have to do anything. It's just keeping one instance running on the old node at all times. And when all of them are moved to the next one, then it's going to reschedule the last one. It's going to promote one of the instances to the primary. And it goes all automatic, as you see. So now number 6 is initializing. It's in a running state. And as soon as that's ready, then we should see another one being rescheduled. Here we go. Now we see number 2 is being terminated. And now it's going to update that one. So if I check my nodes again, we have still one node and the old node is still being drained. So it's now just taking all of the pods from the old node and rescheduling that one to the new one. And when that one is done, it's going to do the next one. And one by one, it's going to upgrade the nodes to the new Kubernetes version. And when you see here, we have the allowed disruptions set to 0. So we always have one primary available at all times. So eventually it's going to just create another instance and promote that, and then we have our primary available on the new node, on the new Kubernetes version. And finally, I just want to show you one more thing, which is that you can also run PGAdmin directly on your cluster. So this is my home lab cluster, and I'm running PGAdmin in a container. It's all available in my home lab repo. And all of these databases are deployed through the EDB operator or the CloudNativePG operator. And I can just check out these tables that I have. For example, this is my Wallabag entry. And if I just go and view my data for the first 100 rows, here I have all of the articles that I have saved in my Wallabag instance, for example. And all of this, again, I can just back up to the cloud. And if something goes wrong, I just restore it to a new database instance. And it works super clean. So running databases in Kubernetes is nothing to be scared of. It works really clean, as you have seen. And in the next video, I'm going to be going deeper into how to run backups so that you can store your data safely in your home lab. So if you found this useful, I'm sure you're going to love my private DevOps community. I have everything you need to start learning Kubernetes from scratch and beyond, and how to set your home lab up from scratch. You only need a Raspberry Pi or an old laptop to get started. You can ask me questions directly and network with over 400 engineers that are available in the community. It's an amazing place. I wish I had this when I got started. So I hope to see you in the KubeCraft community.